Pascal's triangle. Okay. So we're looking at something extremely short period of time so that you can see that it can be used within it. However, Pascal's triangle is just sheer memorization rather than understanding. So I'm completely 100% against memorization, and I'm 100% against understanding, because if all you do is memorize, you will do poorly on tests because you can't read through things. There's also something called a diploma, in which I don't get to see. Every time I look at the diploma, I walk away from it going, my students can do this, I've taught them everything. Now, have you seen every question exactly that way written? No, because I don't see them, right? They can come up with something random, and usually they do, 2 questions out of the 40 that you probably have not seen a question exactly like that before. However, I know you know the material enough and that it's been taught to you that you can do the questions. So nothing on the test is mind-blowingly hard, okay? Can you make mistakes? Sure. But if you understand your math, you will do well. If you just memorize math and that's the way you've gotten through it, that will be a bad situation for you. You need to understand why you do things, okay? Because look at all of these perms and comms questions. They can give you a totally different perms and comms question than I've ever given you. All of them can be different, but they're similar in type, right? They could talk about teachers and students. They could talk about something else that I haven't talked about. They could do a sports team, right? And you may not have seen one like it, or exactly like it, but you've seen something similar. And if you understand the difference between if they're asking you for a permutation or a combination, life is good. It's easy. Okay. Pascal's triangle is this lovely triangle that you start off with a 1, and then below it you get a 1 and a 1. And this actually follows the same route as when you FOIL or distribute out binomials or things to degree 3 or degree 4 or degree 5. That's when you expand binomials. The next row would be a 1. Then you add these. 1 plus 1 is 2, and a 1. Then you get 1. 1 plus 2 is 3. 2 plus 1 is 3, and then you get a 1. You will start and end with a 1. 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 4 is 1. 3 plus 1 is 4, and then 1. And it would just keep going like that onwards. Where is this helpful? Well, if you have a binomial, so for example, x plus 1 squared, a basic binomial. If you expanded it out, and it didn't have coefficients, because if it has coefficients, this throws you for a little bit of a loop. If you expanded it out, you get x plus 1 times x plus 1, which is x squared plus 1x plus 1x, so plus 2x plus 1. And look, 1, 2, 1, 1, 2, 1. So it's the coefficients in front of an expanded binomial when there's no other numbers in front. If there's numbers in front, this only works for partial pieces of it. There's something called the binomial theorem, which is a heck of a lot better. The binomial theorem, the great thing about it is it's actually on your formula sheet on the bottom down here. It says, in the expansion of x plus y to the n, so it has to be in the form x plus y to the n, has to be in that form. So if there's a minus sign between here, you would write it as plus negative y. Okay, so had it been like this, x minus y to the something, n, you would rewrite it as x plus negative y to the n. You need to have a plus sign between it. So just like with the quadratic formula up here, it said it has to be in the form ax squared plus bx plus c equals 0, right? It had to be in that form. Same thing with the binomial theorem. It says in the expansion of x plus y to the n. So if there's a minus sign in there, it has to be a plus sign. Make the minus go to the second term. Okay? Written in descending powers of x, the general term is tk plus 1 equals nck x to the n minus k, y to the k, which sounds awful, but it's not as bad as it sounds. So it's nck x to the n minus k, y to the k. So the reason why this is actually in here is because it has the c in it, that combination. That's why it's involved in this unit. But it has absolutely nothing to do with wordy stuff like the other stuff we did. Okay? It's just algebra. So if we have something in the form of this, we can actually get the solution to the expanded form by plugging it into this formula. So what does that mean? If I have x plus 1 to the 5, I can use that formula and get the 6 terms without having to go x plus 1 times x plus 1 times x plus 1 times x plus 1 times x plus 1. and distribute, 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 and distribute some more, and then collect like some like terms, and then get an answer, which would take forever. So when you think the binomial theorem is awful, think about having to expand that out. X plus 1 times X plus 1 times X plus 1 times X plus 1 times X plus 1. You'd have to FOIL, FOIL, distributing the FOILs, distribute the other bracket into those FOILs once they're distributed to collect like terms. You're probably going to make an oopsie, right? So the binomial theorem is a faster way to expand that out without having to expand it out by literally having to FOIL and distribute. Make sense? All right. So we're going to expand a plus b to the 5 without going a plus b times a plus b times a plus b times a plus b times a plus b and FOILing it all and collecting like terms. We're going to use the binomial theorem. So what does it mean? Okay. Key things to write down. This is your n. It's your n value, okay? You will always have one more than that number of terms. So the number of terms is always n plus 1. So in this case, the number of terms in this specific example is going to equal 5 plus 1, which is 6. Remember, terms are just separated by plus or minus signs, right? So this one, when I expanded it out up here, this x plus 1 squared, it has 3 terms. We agree? This one's just going to get 6. All right? The reason why is you will always have, if you look in this formula, there's an n and a c and a k. This is my n. We agree? It's even labeled as the n in the x plus y to the n. Yeah? The k that you're going to use is always from the number 0 up to n. So in this case, we're going to start off with term 1, which is going to be k equals 0. Term 2 is going to be k equals 1. Term 3, k equals 2. Term 4, k equals 3. Term 5, k equals 6. Term 5, k equals 4. Term 6, k equals 5. So you're going to go from 0 to n. 0, 1, 2, 3, 4, 5. It'll make sense in a second. Okay? So let's expand it and see what we do. Follow along. Don't let me lose you. So we have a plus b to the n, or a plus b to the 5. So we have a plus b to the 5. We know it has to be in this form, right? So we know wherever we see an x, we're going to put in a plus sign, plus sign. Wherever we see a y, we're going to put in a b. And wherever we see an n, we're going to put in a 5 in this case, right? So the only thing that changes every single term is k. Your x stays the same, your y stays the same, your n stays the same. We agree? Okay. So, term 1. I'm just going to write term 1 above it just for now so that you understand the k's. After that, you don't have to write term 1, term 2, term 3, unless you want to. So, term 1. K is always less than the 1 less than the term number, just so you know. So if I'm trying to find the first term, I'm going to fill in k equals 0. You agree? X, y, and n all stay the same. We are always plugging it into this formula here, which is on your formula sheet. So follow along so I don't lose you. So we're going to go n, which is 5, ck, and in this term, k is 0. We're literally filling into here. n, ck, x to the n minus k, y to the k. X is a to the n minus k, so 5 minus 0. And then y is b in this case to the k. And what's k? 0. You're going to need another row below it, just so you know. I'm writing awfully big. And plus term 2. For term 2, what's k going to be? K is going to equal 1. It's going to look exactly the same as this one, but for every 0, I'm going to have a 1. That's it. It's like literally as hard as it gets. And for every 0, I'm having a 1. So I'm going to get 5c1, a to the 5 minus 1, b to the 1. Then we'll do term 3. plus term 3, k equals what? 2. So is 1 less than the term. So now for every 1, I'm going to put a 2. 5c2, a to the 5 minus 2, b to the 2. You can write it over b. We'll deal with that later. You can just keep going. I'm fine with that. Term 4. K equals 3. 5, C3, a to the 5 minus 3, b to the 3. Term 5. K equals 4. Plus term 6. K equals what? 5. And when your K equals the same as your N, you're done. Why would that be? Well, I have 5C5. If I tried to make my K be 6, I'd have 5C6. Can I have 5 objects and pick 6 of them? Does that make any sense? No. So you're going to stop when N equals the same value, because that's as high as you can go. Because N has to be greater than or equal to R. A to the 5 minus 5, B to the 5. Are they always going to make you expand the whole thing out? No. Can they ask for a specific term and you don't have to expand the whole thing out? Yeah. If they ask for term 7, you would just fill in K equals 6. Done. Find one term. You don't have to expand the whole thing. So yes, binomial expansion. If I went a plus b to the 5, right? And I expanded 5 times, distributed to collect like terms, I could get a specific term. Would that take me forever? Yes. If I just ask you for a specific term with the binomial theorem, you can be done in about 1-2 minutes. Way faster. Okay? Probably even faster after you've done it enough. So what's 5C0 in your calculator? One. Does that make sense? I have 5 objects. I choose nothing. How many ways can I do that? One way. I choose nothing. Okay? So it's 1. A 5 minus 0 is a to the 5. What's anything to the power of 0? Anything to the power of 0 is 1. I used to do in grade 10, when I taught grade 10, I draw pig. It was a question on the test, pig, quiz, to the power of 0. And they'd go 1, because it doesn't matter what the heck is in there. It could be a pig, it could be a chicken, it could be anything. It could be you. If it's the exponent of 0, it equals 1, always. So do I have to write multiplied by 1 back here? If I multiply by 1, do I have to write multiplied by 1? Does multiplying by 1 do anything? No. Plus, 5 choose 1. Yeah. No. B to the 0 is 1. Anything to the exponent 0 is 1. Yeah. Like if you go 7 to the exponent 0, it's 1. Yeah. So b to the exponent 0 is 1. So whatever the base is goes away when it's to the exponent 0. But if I had b to the 1, that would be b. Yeah. Okay. Oh, it's that. All right. 5C1 is 5. It makes sense. 5, and I choose one thing at a time. I pick 1, 2, 3, 4, 5. I have 5 ways, right? Because C order doesn't matter. So it's going to be 5, a to the 4, b to the 1, if you really want to write the 1. 5C2. What do you get? 10. 10, a to the 3, b to the 2. 5C3, you also get 10. How in the heck is that possible? How are 5C2 and 5C3 the same? Yes. So if the value between them is the same difference, so 5C2, the difference between that is 3. 5C2 equals 5C3. Just like I said, 10C7 equals 10C3. Does it work with P's? No, only C's. So 10, A to the 2, B to the 3, plus 5C4 is the same as 5C1. So I'm going to get 5A, B to the 4. And then 5C5 is the same as 5C0, which makes sense. There's one way. I have 5 things. I pick them all. Plus 1, B to the 5. Why didn't I write A to the 0? Bless you. A to the 0 is 1. Multiplying by 1 changes nothing. This is my expansion. This is what you would have gotten if you would have went A plus B times A plus B times A plus B times A plus B times A plus B, foiled, foiled, distributed, distributed, collected like terms. You would have got that. Hopefully, if you didn't make a mistake, which you probably would. Okay? So the binomial expansion is great for expanding quickly, but it's also even more so great if I ask you for a specific term, right? If I ask you for a specific term, then you're not having to FOIL the whole thing out and then just find that term. You can just find it easily by taking K one less than the term you're finding. So, flip over. Find the fourth term. We'll do third term. We'll do this one. This one's pretty straightforward. Find the third term. What the heck does that mean? K equals 2. It's the only thing that changes dependent on the term, right? The rest all stays the same. What do I have to remember to do here? My x is 2x, so I'm going to replace all my x's with 2x. But what do I have to remember here? What's my y? Close. It's not 5. The answer will be there for 5. Negative 5. Y. What term has to be between this? It has to be x, what, y? X plus y. Is it plus right now? No. So we would have to rewrite this as 2x plus negative 5 to the 7. It said it has to be in the form x plus y to the n. Is it currently in the form x plus y to the n? No. So this is my x. This is my y. This is my n. Does not change no matter what term I'm finding. We use our formula on our formula sheet. Our formula on our formula sheet is n c k x to the n minus k y to the k. So our n is 7. How many terms total could this possibly give us if we actually found it all out? 8, because we start at k equals 0 and we go to k equals n, which is 8. It's always one more than n, right? Because we start at k equals 0, k equals 1, 2, 3, 4, 5, 6, 7, which is 8 terms. That's why it's 8 terms, because you start at k equals 0 till you get to n, which causes you to have one more, right? Which is 8. Rather than memorizing it's one more than n, it's important to understand why it's one more than n, so you don't try and remember if it's one more or one less, and then you're sitting on the test and guessing. Okay? So we have 7c2. 2x, because that's x, to the n minus k, 7 minus 2. And then y, which is negative 5 to the 2. Do you see how this is an issue if you don't take the negative 5? In this case, you'd be lucky, right? If you forgot the negative 5, we're squaring it. So it's going to turn positive either way. You would have lucked out. Not on a written response because they'd spot it. But on a multiple choice or numeric, you'd luck out. Because whether this is positive 5 or negative 5, we squared, it's going to become positive, right? But what do you think on a diploma they might give you instead? They might ask for the fourth term so that k equals 3, and then we'll know if you didn't do the negative 5, right? Because you keep it positive. Makes sense? All right. So go 7c2 into your calculator. What's 7c2? 21? Now this is what people mess up. Pay attention because it's where we go wrong next. So this is a 5. We agree? So people will write to me 2x to the 5. Is only the x to the 5? The whole bracket is around the 2 and the x, is it not? So what also has to be raised to the 5? 2. Do you see how it's easy to screw that up? Yes. We do not want to be that person. Okay? So they'll have the answer to the 5 not being distributed to the 2. I promise you they will. It's incorrect, but they'll have it. So remember, it's 2 to the 5, x to the 5. So we're going to multiply. These are all multiplied together, see? When brackets touch brackets, that's multiplication. So what's 2 to the 5? 32. X to the 5 times negative 5 squared, which is 25. Now we have to bring all our coefficients to the front. That's 21 times 32 times 25, a large number. Sorry? 21 times 32 times 25. You now really have to speak up because all I can hear is the fan. 16,000. Agree? Disagree? Okay. X to the 5. Okay. Middle term. What does middle term mean? The one in the middle. So the easiest way, what's up? Yeah. The easiest one, the easiest way I find to find the middle term is I just list all the k values. So quiet. And then cancel off on the way till I get to the middle. So I always do this. I go k equals 0, and we're going to go all the way till k equals 10. So k equals 0, k equals 1, k equals 2, k equals 3, k equals 4, k equals 5, k equals 6, k equals 7, k equals 8, k equals 9, k equals 10. I still find there are some people who don't take notes, and I'm blown away by that. It's not going to work out well for you. That's your choice. I'm not moving your hand. Okay. K equals 0 and k equals 10 cancels. K equals 9, k equals 1 cancels. K equals 2, k equals 8. K equals 7, k equals 3. K equals 4, k equals 6. So I'm going to find the term where k equals 5. And my x, my y, my n all stay the same. X is A, y is B, n is 10. You're fine. You can't move your hand. He broke his hand. That was positive, right-handed, and your hand's broken. Positive. Okay. So let's fill it in. N, which is 10. C, what? 5. What term is actually the middle term if we're looking for k equals 5? What term are we finding? 6. Because your term is always 1 more than your k. Remember, there is a middle term, but there's only a middle term when your n is even. Why would that be? Because you always have one more term than the number of n, right? And you need an odd number of terms to have a middle term. So your n has to be even in order for there to be an odd number of terms to get a middle term. Right? Important to understand, not to memorize. Understand, not memorize. 10c5, a to the 10 minus 5, b to the 5. What's 10c5 in your calculator? K is always 1 less than the term. What's 10c5? 252? A to the 5, b to the 5. Tomorrow we're going to finish the harder examples at the beginning of class, because I want to leave you with the easier ones so you can wrap your head around it, because once you have that down, the harder ones are really easy. They're not hard. Just remember, your n stays the same. Your n stays the same. What else? Your x is always the same. Your y is always the same. The only thing that changes is your k. And how is your k based? It's one less than your term you're finding. Literally, that is it. That. It's not even that hard. It's not trickery. Okay? X, y, and n are all the same. You always have one more than the number of n terms because you start with k equals 0. And you have to remember, though, that you need to have a plus sign between your binomial, correct? So if you don't have a plus sign, you need to put a plus sign and make your y be negative. We agree? Okay. Your homework, I'll tell you which questions you have to do because you don't have to do all of them. But remember, you still have that big review to work on. So you need to work on that big review. I'll circle the ones you have to do. Easy. Easy. 4, 5, 6, and 7.